Hey, Algebra and people, we are doing notes today on arithmetic sequence. Now, most of you probably looked at this word and called it arithmetic. Fun fact, you are wrong. This is actually pronounced arithmetic. This is different than the arithmetic that you learned when you were in elementary school, but that's beside the point. All right, something that I want you to do before we actually begin is I want you to try these. I want you to write these down, pause this video, and try. These are just patterns, right? You've seen patterns. Now, another word for pattern is a sequence. And I mean, technically, they don't mean the exact same thing. Like a sequence just means a bunch of numbers, but a pattern means a bunch of numbers that have some way where you could find the next number because they have a pattern. I don't know a better way of putting that, but you get what I mean, okay? So for each of these sequences or each of these patterns, they all have a pattern, and I want you to pause this and see if you can find the next two in each of these. Okay, ready to go? No, really, pause it, try it, do it. Okay, now since you have the ability to pause this, I don't actually have to wait, which is awesome. I should have mentioned too, write a description of how you know the pattern. Describe the pattern, like what's happening. But you should have already done that. If you didn't, pause it right now. Anyways, I'm rambling. All right, so this first one, you should have looked at this and said, well, 3, 5, 7, 9, 11. The next two would be 13 and 15. Then you could have said something simple like add 2 every time to get from 3, oh, that's weird, every time. To get from 3 to 5, we add 2. To get from 5 to 7, we add 2. 7 to 9, we add 2. 9 to 11, we add 2. So the pattern there is I'm just adding 2 to get from one number to the next. All right, number 2 here, let's see, 2, 7, 12, 17, 22. You should have said 27 and 32. Now, there's a couple of different ways to figure out this pattern, but the simplest, in my humble opinion, is you add 5 every time. Same thing, to get from 2 to 7, you're going to add 5. To get from 7 to 12, you're going to add 5, so on and so forth. You add 5, blah, blah, blah. Okay? All right, this one was tougher. Negative 416, negative 323, negative 230, negative 137. Now you might have a calculator, figure out how I get from one number to the next, and you may have already figured out based on these two that it looks like I'm adding every single time. And so I actually, to get from negative 416 to negative 323, I add 93. If you don't believe me, check it out. Negative 416 plus 93 gives me negative 323. And if I add 93, I get negative 230. And if I add 93, I get negative 137. That's the 4 numbers that I currently have. So if I want to follow that same pattern, I add 93 again. This would have been negative 44. And then last time, if I add 93 one more time, this would have been a positive 49. And you are adding 93 every single time, right? All right, here's the last one. This might have tricked you. I hope not, but it should have been negative 14 and negative 17. Now, this one's slightly different because I am not adding to get from one to the next. I am subtracting 3. Minus 3, minus 3, minus 3. So to get from one to the next, I subtract 3. So I would take negative 11 minus 3, which gives me negative 14, which I'm guessing a lot of people can do that in your head. But, for consistency's sake, because the other 3 were addition, and this one's not addition, why don't we not say it in terms of subtraction, but let's say it in terms of adding. So subtracting 3 is the exact same thing as adding a negative 3 every time. Yep. So like if I came back over here and I said, well, I'm going to add a negative 3 and then add a negative 3, add a negative 3, add a negative 3, it's the same thing, right? Hey, we got some patterns. Now, All of the patterns above, again, these are called arithmetic sequences. Arithmetic sequences. That's the important thing here. Now, arithmetic sequences are sequences of numbers where, and here's where you would just give a general description. I'll tell you my Hayward definition. Numbers where you get from one number to the next by adding. Now, here's where I'm going to give you your first bit of vocabulary. By adding a common difference. A common difference. All right, now if I come back up here, problem number 1, this 2 that I'm adding every single time, that is called your common difference. And we have a letter to describe that. We're going to keep it easy and we're going to call it a D. D stands for difference, right? A common difference. All right, so for number 1, your common difference is add 2. For number 2, your common difference is 5. For number 3, your common difference is 93. For number 4, your common difference is a negative 3. So slightly different because I'm going down here, so my common difference is negative. So, arithmetic sequence, it's basically just a bunch of numbers, and to get from one number to the next, you're going to take a specific number, your common difference, and you're going to add. That's all an arithmetic sequence is. Now, before we get to what's next, I just want to tell you where arithmetic sequences come from. Arithmetic sequences are basically just lines. Yup. Okay. Y equals, let's see, 2x plus 3. That should look super familiar, right? Y equals 2x plus 3. That is a line in slope-intercept form. Now let me show you something cool. If I were to make a t-chart of x's and y's, and I were just to start writing x's, 0, 1, 2, 3, 4, 5, 6, and I want to see what would happen if I take all these x's and I plug them in. So 2 times 0 plus 3. Well, you should say 2 times 0 is 0 plus 3. This is equal to 3. 2 times 1 plus 3. Well, 2 times 1 is 2 plus 3. Oh, that's equal to 5. I don't know why I wrote that in black. Keep my colors consistent. 2 times 2 plus 3. Well, let's see. 2 times 2 is 4. 4 plus 3 is 7. Let's do one more. 2 times 3 plus 3. Well, 2 times 3 is 6. Plus 3 is 9. Now, you might already see the pattern here. 3, 5, 7, 9. Yeah, this is the pattern from number 1. 3, 5, 7, 9, 11, 13, 15. So this should be 11, 13, and 15. You double check that really quick. You could plug in like 4 here. 2 times 4 is 8, plus 3 is 11. Plug in 5. 2 times 5 is 10, plus 3 is 13. Plug in 6. 2 times 6 is 12, plus 3 is 15. And all I'm doing to get from one to the next is I'm adding 2, which is in this case my slope. A common difference and a slope are basically the same thing. But we're taking this off of a graph. We're taking this equation off of a graph and saying, what would it look like if we just looked at your y values? Plugging in, starting at x equals 0, x equals 1, 2, 3, 4, 5, plugging in y, or those x values and see what you get for your y values. So that's where arithmetic sequences come from. They're just linear stuff. Cool? All right. Now let's come here. Now, I want you to try this again without me. I want you to pause this video, take a minute, and tell me, is the sequence arithmetic, why or why not? Actually, before you start, I'm going to show you an example of something that is not arithmetic. And for that, I'm going to look at number 7. Number 7 is not arithmetic. Not arithmetic, and I'll show you why. If I go from my first number to my second number, it looks like I have to add 2. If I go from my second number to my third number, 3 to 6, it looks like I add 3. 6 to 10, I'm adding 4. 10 to 15, I'm adding 5. Is there a pattern here? Yes, absolutely. Add 2, add 3, add 4, add 5. So if I wanted the next number, I could add 6 and I could get to it. But even though there's a pattern, that is not an arithmetic pattern. Arithmetic is when you have the same number being added every single time. So this is, I should just write no, not arithmetic. So I'm going to write no. Okay, pause. I want you to look at the rest of these, the other 5, and take a minute and figure out if they're arithmetic, yes or no. Okay, ready, go. All right, again, I don't have to wait. So let's see how good you are. Number 5, let's see. From 6 to 10, I would add 4. 10 to 14, I'd add 4. 14 to 18, I'd add 4. 18 to 22, I'd add 4. So number 5, I would say, yes, it is arithmetic, because every single time, D is equal to 4. Remember, D is my common difference, the difference in between any two of these. And I can find that pretty quickly. Take any two numbers and subtract the second from the first. 18 minus 18 minus 14 gives me 4. Take two other numbers, like if I took 22 and 18. 22 minus 18 is 4. So if I take any two numbers that are right next to each other, I subtract the second from the first, I should get that common difference. All right, let's try here. Number 6, if I go from -8 to -1, that looks like I am adding 7, okay? Going up 7. Would you find out pretty quickly, again, if I took -1 minus -8, it gives me 7. So let me do the same thing for these two numbers, -1 and +8. I'm going to take the second one, which in this case is 8, and I'm going to subtract the first one, which is -1. So if I'm going from -1 to +8, it looks like I have to go up 9. Some of you might just do that in your head, and that's okay too. Boom, I don't have a common difference, so I would say no, not arithmetic. There might be a pattern, I don't know, but it's not arithmetic. We did this one. Let's look at number 8. 32 to 21. Well, shoot, that it looks like I actually have to go down 11. I have to subtract 11 or add a -11. Let me show you really quick. If I do 21 minus 32, it gives me -11. So if I did that for all of these, from 21 to 10, 10 minus 21 is -11. Going from 10 to -1, I have to go down 11, and -1 to -12, I have to go down 11. So I would say, yes, I have a common difference of -11. Ooh, whoops. That light's turned off on me again. All right, let's look at number 9. So to go from 50 to -40, oh, goodness gracious. Again, I can take my little trick I just learned, and I can say -40, that's the second number, subtract 50. Oh, it looks like I had to go down 90. That's kind of a lot. Now from 40 to 30, I'm going to do that -40 to +30. Same trick. 30 minus -40. That gives me, I'm actually going up 70. That's a hard no. Look at it. First you went down, then you went up. That's definitely not arithmetic. Definitely not a common difference. Last one, number 10. Well, let's see. If you're not good at mental math, again, that's fine. Just grab a calculator. To go from 128 to 205. So I take the second number. Let's just clear this. 205 minus 128. That gives me 77. So from here to here, looks like I'm going up 77. Now we're going to do the exact same thing with the next two. I'm going to take 282, and I'm going to subtract 205. And it looks like I got 77 again. Now, some of you might want to be tempted right now to be like, oh, it's probably a common difference. And you might be right. But I'm going to check every single one. Now, all I have to do, if I think it's an arithmetic sequence, 282, if I add 77, I should get 359, and I hit enter, 359. If I add 77 again, I should get 436. So my numbers add up. I would say yes, I had to add 77 every single time. All right, kind of getting the idea of an arithmetic sequence? Okay, before we continue, I need to give you a little bit more vocabulary. Now, we already did this one. The difference between each number in an arithmetic sequence is called the common difference. Okay? Now, I'm going to take a specific arithmetic sequence here so I can show you some vocabulary. Let's do this first one. 6, 10, 14, 18, 22. Cool. Right? I'm going to get different paper. I wrote on that one. I think you can see through it. Let's try this again. 6, 10, 14, 18, 22, whatever. Okay. Now, this is a sequence of numbers. Okay. Now, currently, you are looking at 5 terms of the sequence. All of these are terms. Okay? Terms just refers to any number in a sequence. So that's my first term, my second term, my third term, my fourth term, my fifth term. Okay? Now we're going to get specific and we're going to label these. Now, terms in a sequence use a lowercase a. I have no idea why. But then they also use a number. So this is my first term, my second term, my third term, my fourth term, my fifth term. I could go on and I could find other terms. So again, don't know why, but your first term is A sub 1. Your second term is A sub 2, A sub 3, A sub 4, A sub 5. These are just labels. So if I were ever talking about like A sub 16, that is referring to the 16th term. Okay, just keep that in mind, right? Now, again, if I'm talking about the difference from one thing to the next, like in this case I have to add 4, that is called the common difference, which you're going to hear a lot, and that we use the letter D. Now, that's pretty much all the vocabulary you need to know. These are all called terms in a sequence. Each term's labeled with lowercase a, and then a number, a sub-number, meaning it's a small number below. And then the common difference is what you have to add or subtract to get from one term to the next. All right, look at the bottom here, the explicit formula for any arithmetic sequence. Okay, and then these are types of questions that you would hear for arithmetic sequence, like find the common difference, write the rule equation for the given information. Just that's asking for the explicit formula, and I will tell you what that is in a hot second. Now, you should be able to pretty quickly in something like this find the common difference. If I tell you this is an arithmetic sequence, you should be able to look at this and say, well, what do I do to get from one term to the next? 10, 15, 20, 25, 30. Oh, it looks like every single time I'm just adding 5. So D equals 5, so on and so forth. But I'm going to come back to this sequence right here, and I'm going to show you an interesting pattern. Now, we said that our first term is 6. Okay. Then we said our second term was 10, but that was just 6 plus my common difference, which is 10, right? Then we said my third term is 14, but that's because I took 10 and I added 4 again. So I had 6 plus 4 to get 10, and then I added 4 one more time, and I got 14. So 6, 10, 14. Well, my fourth term was 18, but that's because I had 14 plus 4. But that's because I had 10 plus 4. But that's because I had 6 plus 4. So I took my first term, I added 4 to get my second term, I added 4 to get my third term, and I added 4 again to get that 18. So you can see our 6, 10, 14, 18. Let's do one more here. Now my fifth term, okay, my fifth term is 22. Take a few seconds and tell me, I'm going to write 6 plus, how many 4s am I going to put right here? This is my fifth term, how many 4s? You should have answered 4 of them. 6 plus 4 plus 4 plus 4 plus 4. Now, we haven't even done, or we haven't figured out the 6th term, 7th term, anything like that. I'm going to see how smart you are. I'm going to write my 11th term. Now, I have no idea what the 11th term is right now, but I'm going to ask you, how many 4s should I write? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you said 10, you are correct. And 6 plus 10 4s is 46. Now, you're probably seeing the pattern here. My first term is 6. My second term, look at this number right here. My second term, I only had a single 4. My third term, I had 2 4s. My fourth term, I had 3 4s. My fifth term, I had 4 4s. So whatever term number it is, 2, 3, 4, I'm going to take that term number, like for instance, 11, and I'm going to subtract 1 from it, and that's how many 4s I'm going to write. And that's because I didn't need a 4 on my first term. So I needed 1 on my second term, 2 on my third term, so on and so forth. So if it's my 11th term, I actually only need 10 4s, because I took 11 minus 1. Now, I told you I showed you all the vocabulary. Technically, I didn't. These numbers right here are described by the letter N. N is just saying the number term, N. So, like, if I have the 11th term, that's because N equals 11. That's because the number term is 11. Pretty quick, right? So I'm going to write something a little weird. If I wanted a sub N, meaning if I want a generic term, well, for this, I'm going to take 6, right? And then I'm going to add 4, but how many times? Well, just like up here, we took whatever this number was, and we subtracted 1. So currently that's an N. N minus 1. My first term plus my common difference, N minus 1 times, right? So let me give you an example. If I wanted, let's see, if I wanted my 21st term, I'd take 6, I'd add 4, let's see, 21 minus 1 times. Now, instead of actually saying, well, that's 21 minus 1 is 20, so 6 plus 4 plus 4 plus 4, 20 times. No, we don't need to do that. We can take a shortcut now. I can say 6 plus 4 times 20. And I get that my 21st term is 86. 86. Yeah, kind of cool. Now, this right here, this is an example of an explicit formula. An explicit formula. 6 plus 4 times n minus 1. Now, I could show you something even cooler, and I will, because I like this nonsense. But a sub n equals 6 plus 4 times n minus 1. If I wanted to, I could distribute this, right? I get 6 plus 4n minus 4. Well, then 6 and a negative 4 come together to make 2. Now, that should look kind of familiar. Doesn't that kind of look like slope-intercept form? Yeah, that's because it pretty much is. But for right now, we're actually not going to do this. We're going to keep things simple. We're going to keep things like this. Okay? Now, a sub n equals 6 plus 4 times n minus 1. That was the explicit formula for one very specific sequence. So when I gave you 6, 10, 14, 18, 22, here's the explicit formula for that one sequence. Now, let's say if I wanted the explicit formula for any sequence, here's what I'm going to write. First term, so that's a sub 1, plus my common difference, which is d, times n minus 1. Now, we took a long time to get here, but the good news now is you can use this. A sub n equals the first term plus your common difference times n minus 1. You'll also sometimes see a sub 1 plus n minus 1 times d. You'll see the d on the outside. It really doesn't matter. I'm going to keep it like this, right? Okay, now let's come back here. Okay. So the explicit formula for any arithmetic sequence we just said was, explicit formula for any arithmetic sequence is the first term plus my common difference times n minus 1. All right, so really all you need is two things. You need to know what my first term is. You need to know what my common difference is. That's it. Cool? All right, so let's try. So we're on number 11 here, correct? Number 11 we already looked at and we said, okay, I know what my common difference is. My common difference is 5. Let's ignore these for a hot second. My common difference is 5, and my first term is 10, because that's the first term. I can plug those two things in and I can write my explicit formula. A sub n equals my first term plus my common difference times n minus 1. Hey, look, I'm done. That right there is my answer. Explicit formula. All right, let's do the same thing over here for 12. Well, I know my first term. That should be pretty easy. Usually if it's written like this, it's going to give it to you. But now I need to find my common difference. How do I get from 32 to 25? Now you know this is arithmetic, so you can pick any two numbers that are right next to each other. I usually just pick the first two. And I'm going to do my little trick. 25 minus 32 gives me a negative 7, meaning to get from one term to the next, you subtract 7. So my common difference is a negative 7. Okay? So a sub n equals my first term, which is 32. Now, some people are tempted to write plus negative 7, but you don't need to do that. It's the same thing as minus 7 times n minus 1. Because when you add a negative, it's the same thing as subtracting. Just like we said at the top, instead of subtracting, we said we were going to add a negative. That's my answer. And I'm done. If you're ever asked for the explicit formula, you just need those two things. First term, common difference, and you're done. But it can't stay that easy forever, right? Now we've got some more fun stuff. Check this nonsense out. Find the indicated term of each arithmetic sequence. Now look, I give you a hint. First find the equation, and then plug in your n. So here's what I mean. 13, it looks like we're trying to find the 25th term. 25th term, right? So all I need is two things to write my equation. I need, back up here, I need my first term, my common difference. I have my first term, that's 62. And it looks like my common difference, to get from one term to the next, it looks like I am subtracting 4. 62 minus 4 is 58. Made it a little bit more clear there, okay? Or again, you could come, if you have a calculator, and punch in 58 minus 62, and it comes up with a negative 4. Still the same thing. So now I've got my common difference, and I've got my first term. So I'm going to write my formula. A sub n equals, let's see, my first term is 62 minus 4 times n minus 1. Nice. But I'm trying to find a sub 25, which means in this case n is equal to 25. I'm trying to find my 25th term. So I could write 62 minus 4 times 25 minus 1. How'd you look at that? 62 minus 4 times 25 minus 1. And actually, I'm not even going to do this by hand. You just punch that whole thing in a calculator if you have it. 62 minus 4 times 25 minus 1. Enter. And I get a negative 34. Negative 34. So if I kept going and I subtracted 4, subtracted 4, subtracted 4, subtracted 4, subtracted 4, all the way until I got to the 25th number, it would be negative 34. Now, if we wanted to get technical, I should write a sub 25 equals negative 34. That would be like what a good final answer would look like. Cool? All right, let's try one more and then we will pause or be done. All right, so I'm going to write my equation. So any term is my first term, negative 13, plus my common difference. Well, to get from negative 13 to 0, I add 13 times n minus 1. Okay, but I don't just want any term. I'm going to rewrite this without my n's. I want a very specific term, which in this case is the 17th term. So I'm going to take out n and I'm going to plug in 17. So again, you don't have to do this by hand unless you really want to. You can punch this all in at once. Negative 13 plus 13 times 17 minus 1. And I get that my 17th term is 195. So a sub 17 equals 195. Now, I'm going to take a hot second to just go back and see, does that make sense? Well, is my sequence getting bigger or smaller? Negative 13, 0, 13, 26, 39. It's getting bigger, right? I'm adding 13 every single time. At my 1, 2, 3, 4, 5, my 5th term, I'm at 39. And then I'm adding 13 every single time. So at my 17th term, does it make sense to be around 195? Yeah, that's significantly bigger. I'm going to add 13 quite a bit more times. So yeah, that's not checking an exact answer. That's just in my brain saying, yes, this makes sense. Okay, quick recap. Arithmetic sequence. Arithmetic sequence. I'm going to put this back up. These are all terms. A and a little number is the label for them. And then the distance in between two terms is called a common difference. And if that difference is the same every single time, we call it an arithmetic sequence. That's it. And then lastly, the explicit formula. This is something you're going to want to know, although you're going to be able to use your notes on all your assessments, so whatever. A sub n equals... Oh, I didn't show you I showed you a specific one. A sub n equals your first term plus your common difference times n minus 1. This is the vague one that you can use as like your template, and this is a specific example for a specific arithmetic sequence.